Thank you for your kind introduction. First, I want to say it's a great honor to me to have a presentation in front of such experienced experts. I'm just at the beginning of my research path, so I found this opportunity perfect for me to start. I will talk about energy efficiency of CLT frame with laminated glass infill. That's the topic that is active today. So it's more or less, I will be talking about facades and energy efficiency. First, my presentation will be agenda is, I will give you a short overview, a short brief introduction. Then I'll talk about prototype of multifunctional composite wooden bearing glass system. You will see we built a small live laboratory. Then I'll show you the installation and problems with that. Then the test program, measurement scheme, and in the end I will conclude with result and further research. Before I start talking about facades, we need to have in mind that we have to look our facades from two aspects. First is architectural perspective, and second is engineering perspective. The most important aspect from architectural perspective, from design standpoint, and it set the tone of the rest of the building. We need to pick up the material, the aesthetic, the energy efficiency, and of course in the end statics. This is some examples of how facades can look, and my topic is more or less about wooden facades with bearing glass infill. These are some nice architectural facades, but of course I need to think more like an engineering, and the engineering perspective is like this. We can see the little picture nice here that show us what we need to have in our mind when finding a solution for good facade. So the facade is of great importance due to its impact of energy efficiency. In Europe, one of the most important legislative instruments aiming at improving the energy efficiency of European buildings. So taking that into account, we need to provide all the details, all the thoughts, and design the facade to be energy efficiency, and that's all. Of course, you can see in the pictures we have to take care about maintenance, acoustic, thermal, protection from environment, fire, durability, and sustainability. Before I started to research this topic, my colleagues before have been researching about statics, so I will just tell you a sentence or two about that, and then I'll go to the energy efficiency. So our laboratory consists of timber, of CLT timber and glass, and the first problem that we had is glass, because we all know Eurocode, and the Eurocode, it's not everything clear about glass. So that's the first problem that we took care of. So just few sentences about glass and the glass we used in our facade. So the glass, here we can see the tension and compression comparison to the other materials, and here we can see the all kind of different kinds of glass, such as laminated glass, heat strengthened laminated, and annealed in pre-stress. At the first preliminary testing, we used the laminated glass, and it showed good result. Second material that we used is timber. We used CLT, so I just with this picture wanted to show you two things. The first one is that in timber and CLT elements we can build multi-story buildings. So the timber is of course has a good energy efficiency characteristic. Second thing I want to point is that environment. And this is the comparison between building in timber and building in concrete, so you can see the difference. Okay, so now we come to our prototype, our live lab. We call it live laboratory. You will see in the next few presentation why. So just a few sentences, a few thoughts about our project. This project is already running for 2 years, and it's 1 year to go. And as you can see in these pictures, this is 3D model that I made. You can see the CLT frame and glass infill. The only difference, you can see it now, and you can think about it. Just it's a regular window, but the difference is that this glass is bearing element. So yeah, that's the main difference. I will show you a quick video. I'll speed it up a little bit, but of how we install it and of what elements it consists. So we have to take care about every single detail. The first part was to install the CLT frame. CLT frame, I didn't talk a lot about it because I talk about energy and not statics, but CLT timber is the cross-laminated timber. So you have 3 or 5 or more layers, and that shows better behavior. So this is our 2 elements. So it's the CLT frame with glass infill. We had to make it before, and then just put it on the roof or our faculty. So I forgot to say where I'm coming from. I'm coming from Zagreb, and this is the Faculty of Civil Engineering. So we install it on the roof of the building of the Faculty of Civil Engineering to show students to have a good view of everything. And yeah, it was good. So this is it's already there like for 1 year, and it's 1 year to go. And I'll talk about it, what we have been done and what are we planning to do. So this is just a short overview, short video to show you how it looks like. The next thing after we install it is actually energy, finally. So this is our measurement scheme. So we have a lot of measurement instrument that we want to check every detail and see the problems and design the proper way. So we have thermocamera, heat conductivity meter, interglass layer. On the roof we have solar panel, and of course we have cloud communication and meter station to take care of everything. So after we did the test results obtained according to the presented program will enable us to develop the thermal characteristic of the vetrolignum. Vetrolignum is the project, the name of project. And we need to put it in accordance with the applicable technical regulation. What are the problems and challenges? So the main problem is optimizing its insulation characteristic. We had some problem that I'll show you in the next presentation, and we want to bring it into compliance with the requirements of regulation and national European level. Acquiring the thermal characteristic of the panel and obtaining parameters for the construction design in accordance in the applicable technical regulation. Some more challenges are measurement of internal temperature and humidity, and based on the measurement result, the thermal properties of the composite panel will be improved and contribute significantly to the raising of level of its technological readiness. What the approach, what the methodology? As I told you, we divided the project into few phases. Exactly in 3 phases. The first phases was that mock-up on the live laboratory. It's examined with double and laminated glass panels. At the stage, this facade is covered by a wooden sandwich panel in order to measure the influence of the object and orientation. In the second phase, the mock-up with the wooden panel will be removed, and the glass will be only left. So we will see the difference and the measurements. The third phase actually is happening right now. I came yesterday from the laboratory. Then we put in the big laboratory realistic panel, realistic facade, and we want to test it due to air permeability, wind permeability, and energy efficiency. I'll show you now. And the last thing after we did the test, we do numerical modeling to save us some time and to save us some money, and because it's not always possible to do the test because of lack of money and time. This is just the preliminary numerical modeling of our facade, and it shows us the required energy, heating and cooling through the year. The last phase that I told you that I was there yesterday is facility test in one private company called KFK in Croatia, in Zagreb. And this test in the red zone we have already done. So it's air permeability, resistant to wind load, water tightness, dynamic and statics. This green synthesis, this green test was done before by my colleagues, and this blue test we are planning to do, it's more or less about sound. Here we can see our facade. So this test is about efficiency, about air and rain and water. This is the view from another view, and this here in yellow shirt, it's me crossing my fingers to test to pass, to verification. This is dynamic test, same about water, and this is what are we planning to do with the sound. And to end this presentation, I would like to show you how it looks here. So what
KFK Test Laboratory is equipped with test and measurement equipment for testing of building block elements in accordance with European product standards EN 13830. Suspended facades, product standard EN 14351. Windows and doors, product standard. Apart from the tests specified in European product standards, the FPC Examination Laboratory may conduct tests that require markets outside the European Union, such as markets United Kingdom of Great Britain and Northern Ireland, where there are national standards and guidelines for testing and evaluation of overcast sections of the building envelope. CWCT, Standard Test Methods for Building Envelopes, issued by Centre for Window and Cladding Technology. United States, where there are national standards issued by the American Architectural Manufacturers Association, known under the AAMA, and standard number. All test and measurement equipment used during the test are moderated by accredited laboratories within the prescribed time periods. Below is a list of properties that can be tested in the KFK Test Laboratory. All tests in the KFK laboratory that are not intended for their own research or needs are carried out in the presence and conduct of testing by authorized and accredited institutes and laboratories.
And just to conclude, why I didn't talk too much about energy, because this is the first preliminary phase of our energy efficiency test, and we have just preliminary test, and actually we are waiting the end of this week to get some results and to know what we have to take care about and to design the details. But yeah, I just wanted to show the beginning of our project, and that the final stage is now to design the details to be more energy efficiency. So that's all from me.